Hey guys, today I'm going to teach you all about the Pythagorean Theorem. By the end of this lesson, you'll be able to identify parts of right triangles and use the Pythagorean Theorem to find the missing side lengths of those right triangles without measuring. So go ahead and get your binder, turn to the math section. Let's go ahead and take some notes. Alright, so let's start by labeling parts of a right triangle. The first thing you do when you see a right triangle is find the right angle. The right angle is the little square. The two sides that make a right angle are called the legs. And we always label the legs with an A and a B. So the word adjacent, you'll see here, adjacent just means side by side. So the ones that are next to the right angle are known as the legs. Because they're both the legs and they both make a right angle, it doesn't matter which one you label B or A. You can switch it around as long as you know that the legs are what makes the right angle. Now the third side of a right triangle is different, and this one can only be referred to as the hypotenuse. It's always the side opposite from the right angle. So always try to find the right angle, and I like to draw an arrow, and it points to the hypotenuse. The longest side is the hypotenuse of this right triangle. We would label it C. It's really important that you know how to label parts of a right triangle, because this will be used for our Pythagorean theorem. The way I remember it is there's always a little square between the legs, and then the way I remember the hypotenuse is it's like this is the ramp. And so I always think I see a hippopotamus sliding down the ramp. And I use the word hippopotamus for hypotenuse because they sound similar. A lot of people will mistakenly call the longest side of the right triangle the hippopotamus. You know it's the hypotenuse, but it helps you remember it. You can always think, I see a hippopotamus sliding down the ramp. All right, so before we go on, take a second and look down here and label A, B, and C on each of the right triangles below. Pause the video now to do that and press play when you're ready to check. All right, so this is how you should have labeled these four right triangles. Remember, A and B are the legs, and they make the right angle. It doesn't matter which order you put A and B, but it does matter where you put C. C is always the longest side, and we would call that the hypotenuse. If you're having trouble identifying C or the hypotenuse, just remember you can always find the right angle and think about drawing an arrow from it, and that'll point to the hypotenuse. You could also remember it with the hippopotamus. You can think, I see a hippopotamus sliding down the ramp. Even when it's rotated around or reflected, this is still C. I will say the hippopotamus hypotenuse thing is kind of cute and easy to remember. But if you look at this one, people have trouble with this one because they're like, there's no ramp for it to slide down. So I just wanted to show you that it might not always look like a ramp for it to slide down. It might look like this. And in this case, people get confused and they think, okay, one of the legs is the ramp. So they think this is the hypotenuse. But if you notice, this is still the legs. The legs make the right angle, and that's always the case. So if I was you, I would always find the right angle and identify that A and B are the legs. The third side is the hypotenuse. And it's really important that you know how to label parts of a right triangle, because that's how we use the Pythagorean theorem. The Pythagorean theorem tells us how the side lengths of right triangles are related. There's a special relationship between the legs and the hypotenuse. So here's the definition of the Pythagorean theorem and some really fancy math words. Then I'm going to break it down to make it a lot easier for you. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Let me show you what that looks like with a picture. What I'm going to do is I'm going to take these three squares. I'm going to build a right triangle with them. So I'm going to make a right angle out of these two. Then I'm going to use this big one with the longest sides. I'm going to make that the hypotenuse. I'm going to make that the longest side C. So now that I connected them, I have a right triangle here in the middle. Now what we just wrote was in any right triangle, the square of the hypotenuse, that's this square here, since it has a side length of 5 square units, I know in total there are 25 square units here. And that hypotenuse square is equal to the sum of the squares of the other two sides. Sum means add. So I'm going to add up these other two squares and I should get 25. Since this square in red has a side length of 3 units, I know that in total there are 9 square units. And the blue square has a side length of 4 units. So in total, there are 16 square units. Now again, if I add up the squares of the legs, I should get the square of the hypotenuse. 16 plus 9 is 25. So that makes the Pythagorean theorem true. So what you'll start to see is this. You'll get 2 lengths of a right triangle. You'll know that those are the legs because they make the right angle. And it'll say solve for C, or the hypotenuse. You know that the square of A plus the square of B, and remember that little 2 means squared, equals the square of C. You would substitute your values into the formula, simplify what you can, and when you get to this last step, you would have found the square of the missing side. But if you just wanted the side length, you could always do the inverse operation of squared, which is the square root. The square root of 25 is 5. So you have this really complicated definition. You just saw me do it with a picture of it and explained why the Pythagorean theorem works. But at the end of the day, the only thing you need to know is that a squared plus b squared equals c squared for right triangles. As long as you can label parts of the right triangle, you know that the legs make the right angle, and c is the hypotenuse, the longest side, you can always solve these kinds of problems. For example, in 1, 2, and 3, we have a missing side length. The missing side length in all these problems is the hypotenuse. I know that because each of these legs makes a right angle. So I might want to start out by just labeling each leg as A and B. And then I'm going to use the Pythagorean theorem to find the missing side length. We've already done number 1. So see if you can try to remember how to do it by yourself. Pause the video now and press play when you're ready to check. All right, so we just saw this example, and I'm going to point out a few things. The numbers 3, 4, and 5 are called a Pythagorean triple. That means that there are 3 whole numbers that perfectly satisfy the Pythagorean theorem. They're side lengths that could make a right triangle. Number 2 is another example where you'll get a Pythagorean triple. The length of the hypotenuse is a whole number. So try to find number 2's hypotenuse by yourself. Pause the video now to do that and press play when you're ready to check. All right, so the first step should be to write out the Pythagorean theorem. A squared plus b squared equals c squared. Then you want to substitute your values. It doesn't matter the order that you put the legs in because of the commutative property. When you add them together, you'll get the same number. In this case, 625. Now, I know that 625 is not the length of C. That's way too big to make this a right triangle. That's because 625 represents the number of squares it would make to make a square that would fit onto this right triangle. So C squared is 625. If I want to know what just C is, I need to do the opposite of squared. The opposite of squared is to take the square root, and you want to take the square root of both sides. That cancels out that squared on this side, so C equals the square root of 625, which is 25. Now, number 3 does not give you a Pythagorean triple. You're not going to get a whole number for the length of the hypotenuse, but you will get a number that you can approximate. So I want you to round to the nearest tenth when you get to that last step. But please try number 3 by yourself. Pause the video now to do that and press play when you're ready to check. All right, so you want to start out by writing the Pythagorean theorem, a squared plus b squared equals c squared. Then you want to substitute in your values. Doesn't matter the order you put them in because you will get a sum of 193 either way. And remember, that's what c squared is. But we want to know what just c is. We want just the length of the hypotenuse. So you have to do the inverse operation. The opposite of squared is take the square root. And the problem here is that 193 is not a perfect square. There's no number times itself that gives you 193. So when you take the square root of 193, it's going to be an irrational number. So I got 13.89 blah, 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 but it's asking me to round to the nearest tenth. So I'm going to find the tenths place. I'm going to look next door. If it's 5 or more, I'm going to go 1 more. In this case, it is. So 13.9 feet would be the length of my hypotenuse. All right, so in all 3 of these practice problems, we just used the Pythagorean theorem to solve for the hypotenuse. But in the next 3 problems, we have the length of one of the legs and the hypotenuse. So this process is going to be different. So watch me do number 4. The first thing I want to do is write out my formula. A squared plus b squared equals c squared. Then I want to identify what parts of the right triangle am I given. Since A and B make the right angle, I know that 5 is A or B. It's one of the lengths of my legs. And 13 is the hypotenuse, C, because it's the longest side of the right triangle. If I drew a right angle, it would be pointing to that longest side. Now I need to substitute in my values. 5 is going to go in for A. I don't know what B is, so I'm just going to leave it B squared. And this time I have C. It's 13, so I'm just going to write that in for my formula. I'm going to simplify what I can, so I'm going to do 5 squared and 13 squared. And now I need to solve for the missing leg. Since I'm solving for the variable in an equation, I'm going to draw my line on the equals, and I'm going to use inverse operations to get the b by itself. So the opposite of plus 25 is subtract 25, and I have to do it to both sides. I can simplify 169 minus 25. That's 144. So I know that b squared equals 144. I know that to find what b equals, I need to do the opposite of squared. So square root. The square root of b squared cancels, so it's just b. And the square root of 144 is just 12. So that's how you find the missing side length if you're given the hypotenuse. You solve it like it's an equation. So go ahead and try number 5 and 6 by yourself. Pause the video now to do that, and then press play when you're ready to check. All right, so here's number 5. I chose to use 6 as the B value. It doesn't matter if you choose it to be A or B since they're just the legs. Either way, you should get that a squared equals 64, and the square root of 64 is 8. So one side length would be 8. Since 6, 8, and 10 are all whole numbers and work as side lengths for this right triangle, that will be called a Pythagorean triple. Number 6 is going to leave you with a side length that is not going to make this a perfect Pythagorean triple. It's going to be an irrational number. So the square root of 320 is about 17.9. And you want to make sure that you're using the units that are given to you. So in this case, miles, and then the last one, yards, and then the first one, inches. All right, so here's some applications of the Pythagorean theorem. These are word problems, so it would be a lot more helpful for me if I would draw a picture. So you're going to want to draw a picture and work these out just like we did the last 6 examples. So take a second, pause the video now, and press play when you're ready to check all 4 of these problems. All right, so here's your answers to check 7, 8, 9, and 10. If you need me to go over them, keep watching. If you missed one specific one, skip to that part of the video. And if you got them all right, good job, you are done. So on number 7, you're looking at a rectangular pool, so I drew a rectangle. I know that it's 25 by 50, so that would be the width and the length of the pool. That makes a right angle. When I draw the diagonal, that makes a right triangle. So I would do 25 squared plus 50 squared equals c squared. The square root of 3,125 is about 55.9, and that would be in meters. On number 8, you have to draw a picture. Without a picture, you might not realize if you're trying to solve for the hypotenuse or the missing leg length. So the first thing I want to point out is that the blue part, the top of the pole hits the wall at 14 feet above the ground. So from the ground to the top of the pole gives me a leg of 14. Since I'm looking for the length from the wall to the bottom of the pole, that would be this yellow length. That's a leg, since this would make the right angle. So to solve this problem, I would take 17 squared. I would get 289. I would subtract that from 14 squared and get 93. The square root of 93 is approximately 9.6 feet. Number 9 is just asking for the area of the largest square. So a squared plus b squared equals c squared. I know 36 plus 64 is 100. So 100 square units would be the area of the largest square. Number 10 looks like that, except I'm missing the area of one of the legs squares. Now, this is what we started with. This is a Pythagorean triple of a 3, 4, 5. And I know that because 4 squared makes 16, 5 squared makes 25. So the area of box 3 would be 9 units squared, which means that one side length would be 3 units. Now it's asking about the perimeter of that square. The perimeter means I add up all the sides. So 3 plus 3 plus 3 plus 3 gives me 12 units. All right, guys, that's it. If you made it to the end of this video, please put in the comments a Pythagorean triple. You can't use one that's already been taken. So I'm going to use 3, 4, 5. Today we learned all about the Pythagorean theorem. So now you should be able to identify parts of right triangles and use the Pythagorean theorem to find missing side lengths. So now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.